What really happened to your body when we fast? When we fast, our body goes through several changes as it adjusts to the lack of incoming food. Here are some of the key things that happen. Blood sugar levels drop. The body uses up its stored glucose, sugar, in the absence of food, causing blood sugar levels to drop. Insulin levels decrease. As the body's glucose levels drop, the production of insulin, the hormone that regulates blood sugar, decreases as well. The body shifts to burning fat for energy. As glucose levels drop, the body turns to stored fat as an energy source, releasing molecules called ketones into the bloodstream. Hormones related to hunger and metabolism change. Fasting can affect hormones such as ghrelin, which stimulates hunger, and leptin, which regulates energy balance, leading to changes in hunger and metabolism. Autophagy occurs. Fasting can trigger the process of autophagy, where the body breaks down and recycles old, damaged cells, potentially improving overall health and longevity. Autophagy is happening. Autophagy is a cellular process in which the body breaks down and recycles old, damaged, or unnecessary cellular components. It is a normal, regulated process that occurs in response to stress, such as starvation or nutrient deprivation, and helps to maintain cellular homeostasis. Autophagy can also help to remove misfolded proteins, damaged organelles, and other cellular debris that can accumulate over time and contribute to the development of various diseases. During autophagy, double membrane vesicles called autophagosomes engulf the damaged material, which is then broken down and recycled by lysosomes. This process helps to maintain cellular health and can improve overall longevity. While autophagy has been primarily studied in the context of disease and aging, recent research has shown that it may also have beneficial effects on metabolism, immune function, and brain health. However, more research is needed to fully understand the role of autophagy in health and disease. Ketones are organic compounds that are produced by the liver when the body is in a state of carbohydrate deprivation, such as during fasting or a low-carbohydrate diet. They are produced as an alternative source of energy for the body and brain when glucose levels are low. The production of ketones is a normal metabolic process known as ketosis, and it allows the body to continue functioning even when carbohydrate-rich foods are not available. In the context of a low-carbohydrate diet, the goal is to maintain elevated levels of ketones in the bloodstream, which is thought to promote fat loss and improve overall health. There are three main types of ketones: acetoacetate, beta-hydroxybutyrate, and acetone. Beta-hydroxybutyrate is the primary ketone body and is the most efficient source of energy for the brain. While ketosis can be a normal, healthy state for some people, it's important to note that it can also be a sign of an underlying health condition, such as uncontrolled diabetes, and can be dangerous if ketone levels become too high. It's always best to consult a doctor before starting a low-carbohydrate diet or attempting to induce ketosis. SIBO. Small intestinal bacterial overgrowth, SIBO, is a condition in which there is an abnormal increase in the number of bacteria in the small intestine. Normally, the small intestine contains a relatively low number of bacteria compared to the large intestine. However, in SIBO, the overgrowth of bacteria can interfere with the normal digestive processes and lead to a variety of symptoms. Common symptoms of SIBO include bloating, abdominal pain, diarrhea, constipation, and malnutrition. SIBO can also cause nutrient deficiencies and can contribute to the development of other health conditions, such as irritable bowel syndrome, IBS, and inflammatory bowel disease, IBD. The cause of SIBO is not well understood, but it is thought to be related to several factors, including poor gut motility, low stomach acid, and the use of certain medications, such as antibiotics. Diagnosis of SIBO is typically based on symptoms, medical history, and a breath test, which measures the amount of hydrogen and methane in the breath after ingestion of a sugar solution. Treatment for SIBO typically involves antibiotics to reduce the bacterial overgrowth, dietary changes to reduce the food source for the bacteria, and other strategies to improve gut motility and support overall gut health. Stem cell. Stem cells are undifferentiated cells that have the ability to differentiate into various cell types and self-renew. They are capable of dividing and producing more stem cells or becoming specialized cells with specific functions. This unique combination of properties makes stem cells a promising area of research for a wide range of medical applications, including regenerative medicine, disease treatment, and tissue engineering. There are several types of stem cells, including embryonic stem cells and adult stem cells. Embryonic stem cells are derived from embryos and have the ability to differentiate into all cell types of the body. Adult stem cells, on the other hand, are found in various tissues and have a more limited capacity to differentiate into different cell types. Stem cell therapy is the use of stem cells to treat or prevent disease. In this field, stem cells are used to repair damaged tissue or to produce new cells to replace those lost due to injury or disease. Some of the most promising applications of stem cell therapy include the treatment of cardiovascular diseases, neurological disorders, and certain types of cancer. However, stem cell research and therapy is a rapidly evolving field and much more research is needed to fully understand the potential and limitations of these cells. Additionally, the use of embryonic stem cells is controversial due to ethical concerns and the potential for tumor formation. It is important to approach stem cell therapy with caution and to consult with a doctor or medical professional for guidance.